show you that any integer, n is often reserved for integer, and you can do membership uppercase Z here. Okay, that means n is any integer, including 0. Now show that we're trying to show that any integer can be written as the sum of 5 cubed integers. Okay. Now a useful lemma here that I'm going to partially show you where it came from, but I'm not going to prove it completely. It says any multiple of 6 can be written as the sum of 4 cubes, not necessarily distinct. Okay, now it follows from a fairly predictable addition of, let me just write this out for you, n minus 1 quantity cubed, and then you add that to n plus 1 quantity cubed. Okay. Now you'll notice that there's 4 terms in each of these series, but 2 of these terms will cancel with 2 of the positive terms in this series. So this will just add up to 2 terms. And so if you do some algebraic manipulation here, from here it eventually follows. And again, I won't go through all those steps. It's fairly straightforward algebra, but I'm just going to write down the result. What you'll get is that 6n is equal to n plus 1 cubed. And maybe we'll come back and do a concrete example of this, like say for 90, where n would be 15. But any multiple of n can be written as n plus 1 cubed plus n minus 1 cubed. And then you would end up with minus 2n cubed, but you would split them apart like this, so you would write it as minus n cubed minus n cubed again. Okay, and so that is the sum, if you want to call it. It is a sum. Additive inverses can be summed. All right. So this is a cubed integer. This is a cubed integer. These are 2 indistinct cubed integers right here. So anyway, after a little bit of algebra, you can get from this statement right here to this statement right here. Okay. Now, also, now this is something I will take the time to show you because it's not that hard. And hopefully you can see why this would imply the existence of 5 cubes if it's true. Okay. So let's go ahead and take a look here. It says any integer is congruent to its cube modulo 6. Now, another way to write that, ladies and gentlemen, is to write down n is congruent to n cubed modulo 6. And for some reason, modulo 6 is very popular in prime number stuff in here too. I don't know if it's because it's the product of the first 2 primes, why it's so useful, or it leads to easy computations, or maybe a mixture of all that. But anyway, this is fairly easy to see, and it's very clear that n equals 0 and n equals 1 satisfy this congruence. But notice that 2 cubed is certainly congruent to 2, right? That's because 2 cubed is 8 minus, this corresponds to 8 minus 2, which is 6, right? Okay, so that's congruent. Let's take a look at 2. Well, let's do 2 squared too. I skipped that, didn't I? 2 squared is, or no, wait, we're doing cubed. I'm sorry. All right. So 2 cubed is congruent to 2. Let's do 3 cubed. Now, 3 cubed is 27, and it's congruent to 3 because 27 minus 3 is 24, which is a multiple of 6, right? In other words, off to the side, I won't do this for all of them, but 3 cubed minus 3 is equal to 24, which is certainly a multiple of 6, right? Okay, and in a similar fashion, what do we need? We need to check, y'all, the remainders when you divide by 6, namely 0, 1, 2, 3, 4, 5. And so we'll do 4 cubed. And you guys, you can see that's congruent to 3, and I'll just say it rather than write it down. This is 64. 64 minus 3 is 60, and that's certainly divisible by 6. So let's get to 5 cubed, verify that too. Wait, 4 cubed is 64. This should be 4, folks. Sorry. All right, so erase. Let me erase that. That should be 4. Y'all, 4 cubed is 64. 64 minus 4 is 60, which is divisible by 6, okay? Now 5 cubed is congruent to 5. And again, here you would have 125 minus 5 is equal to 120. And 120 is definitely a multiple of 6 because it's 6 times 20, right? So we've shown it. It's definitely true, and I'll just for completeness, 0 cubed is congruent to 0. And 1 cubed is congruent to 1, right? So we've checked all 6 remainders. All 6 remainders. And again, 0, 1, 2, 3, 4, and 5 are the remainders you get when you divide any integer by 6. So it's enough to check this reduced residue class, whatever they call it, okay? So we know we've proven this statement right here that n is congruent to n cubed. But now where does that get us? Okay, well, we know up here, we didn't prove it, but we know that 6n can be written as the sum of 4 cubes, 1, 2, 3, 4, right? And again, you can verify that in about 3 or 4 minutes, all right? And now we know that n is congruent to n cubed, but what's another way of writing that, ladies and gentlemen? That means n is actually equal, not congruent, to n cubed, plus, you guessed it, some multiple of 6, right? I'll call it 6m here. Use a different letter. Okay, but guess what? 6 times any integer is always the sum of 4 cubes, right? So this part right here, let me just write it. This part right here, by our previous lemma here, is the sum of 4 cubes. 4, spell it for literary reasons. Okay, sum of 4 cubes. And again, y'all, I'm just appealing to this quickly stated result up here that any multiple of 6 can be written as a sum of 4 cubes. And again, it follows pretty quickly when you consider this in its alternating series stuff. Okay, so that does it because there's a cube. And then there's 4 more cubes in here. Now, this isn't constructive in any sense, I don't think. I guess it kind of is. I'm not going to go to the trouble to do a concrete example, except I will show you one where this would apply. This result right here would apply. Let's go ahead and take 90, because I just did this one before I did the video. 90 is equal to 15 times 6, right? Okay, so that means that 15, see, n would be 15 right here, right? N would be, 15 times 6. So that would make n equal to 15, right? But notice what that gives us. That's going to give us that 90 is equal to, using this result right here with n equals 15, you get 16 cubed. Plus 15 minus 1 is 14, so 14 cubed. And then minus 15 cubed. And that's sometimes hard for people to get used to. Sometimes you get the impression they're going to be distinct, but they're not always. Sometimes you have to allow for 0 cubed, I guess in some instances. Okay, and that's not obvious. I would have to use the calculator on this one. But according to this identity, this is true. 90 is equal to 16 cubed plus 14 cubed minus 15 cubed minus 15 cubed, okay? And so that's kind of a building block. You know, you could probably get it going on here. It may be kind of hard here. Maybe it just works out nicely, you know? Who knows? But in any event, we proved it. Hope you enjoyed that. And thanks for viewing.